Um, wow, after all these wonderful specific talks, I'm here to give you something vague. Um, Definitely in the leave them wanting more school, I suppose. We'll see how far. Actually, in the course of getting this, I vaguely remember more than I expected. But no, I took this very seriously. I did no research for this at all. I did some Google image searches, and when they came up with articles, I did not read the articles. That is my commitment to ethics and truth when I give presentations to you. I'm serious about this. So this is everything I vaguely remember about machine learning from Papers We Love. For those of you who aren't familiar with, as Ryan just said, the Papers We Love is a meetup that I help organize. It's a way that I like to keep in touch with ideas in the computer science community outside of Custom Ink and help bring them back to everybody. It's an international organization. I've met organizers of the London meetup and people from Singapore. It's been pretty cool. And our local one is hosted here. Every other month. It's here in the Mosaic District. So if you have a chance, check us out on meetup.com. We'd appreciate you coming. We got a lot of interesting topics, and a lot of them have been about neural networks and machine learning. So for those of you who aren't very familiar at all, the neural networks and machine learning, that style of machine learning comes from the idea that people saw neurons and neural networks and thought, hey, this works pretty well, and it's pretty amazing. Though the amazing thing is not just because it's a jumbled mess of internet-connected things, but because it has some power to recognize, where algorithmically it's often very hard to write a piece of software that can say, is this a bird or not? Neural networks have some power to do it, and certainly I think most people in this room have the ability to recognize some of what is or is not a bird better than most programs can. And so that's the amazing thing that researchers wanted to harness in creating neural networks. The problem is that training the neural networks is hard. Learning is hard. You may already be aware of this. As an example, my sister, who has a master's degree in human-computer interaction from RPI, was working on creating a neural network. I've been helping her out with it, with training and stuff. I mean, we'd like to get the thing to just be able to say, this is a picture of her dog and this is not. And honestly, we're not even there yet. We have absolutely no meaningful output as far as that's concerned. Probably take us another year or so to continue with training in order to get it there. But we're plugging away at it, and I'm helping her as best I can. So neural networks are hard to train. It takes years for even ones that are extremely well designed, much less ones we hacked together at a hackathon or not. So currently, the most common way of training neural networks is this approach based on a joke I saw on the internet, where, the reason why this joke is funny is because this is actually how it works. What's 9 plus 10? It's 3. No, it's 19. It's 16? No, 19. 18? No, 19. It's 19. Great, you're hired. This is what we do when we train neural networks these days. I mean, the difference is that we use a few different equations going on at once. And then we make layers of them, and then we make layers of that, and then we interconnect all the layers, and then I got bored of drawing all the lines, but you get the idea. And the weird thing is this approach, while compute intensive, actually works. We go through all these and interconnect all the equations and do the math, and then we take the errors from the output on backwards and try to adjust everything to be closer to truth. We do this hundreds of thousands of times, and we get the hot dog or not app, which actually works. It's really astounding. I mean, there's a bunch of tricks. I'll see how many of them I can get into before my time's out, and if you have more questions about these, feel free to ask me later. I mean, there's a bunch of tricks we can do to simplify them. This slide, which I'm not entirely about to explain in detail, is basically based on the idea that if you're looking at me, you should, for example, see, hey, this is a guy standing with a beard, and if I move over here, I should still look like a guy standing with a beard, and if I move over here, I should still look like a guy standing with a beard. So the idea is to sort of layer your network in a way that you take frames, instead of having a bunch of neurons that recognize a guy standing with a beard here, and a different group that does it if he's slightly to the right, and a different group that does it. You sort of bunch them together. You have one group that's your guy with a beard group, and then they can apply to different layers. The nice effect of this is this actually simplifies the math too, since you're not connecting every single neuron to every other, but using some judicious selection. And we pretty much think that's how this works, but again, we're not certain. I like to think of this that we're at a stage in the research of neural networks that's similar to chemistry, where we're no longer trying to transmute lead into gold, and we have some vague idea that there's a periodic table, but we don't know what all the blanks are. And so it's a very exciting time if you want to get into this research. I've got a bunch more slides here that have to do with ways in which thank you, ways in which neural networks are different than biology, equations that work great in biology, but we do differently in neural networks, and things, fancy stuff that we can do. And if you have any questions about what this is, I guess I have answers, maybe, vaguely, some of them. So thank you very much.